our last speaker for this session is Patricia Pius, who is from University of Oklahoma Health Sciences Center.
Hi, everyone. Thank you for the introduction. My name is Patricia Pius, and I'm a third-year resident at the University of Oklahoma. And today I'll be discussing a medical education project that evaluates the efficacy of the radiation oncology contouring software as an adjunct to teaching gross anatomy to medical students. So just to provide some background, we know that cadavers have traditionally been used as a primary method of teaching anatomy in medical schools for centuries, but more recently there has been a decline in the number of available cadavers at medical institutions due to a global paucity, increasing class sizes, and non-physician medical professions incorporating cadaver anatomy. This leaves us with the question of how best to meet the demand of teaching anatomy without sacrificing the tangible and real nature of what cadaver dissection has to offer. There have been several studies showing that incorporating radiologic imaging into gross anatomy actually improves both a medical student's retention of the material and satisfaction with the learning process. The three-dimensional nature of modern imaging helps students understand the relationships between organ systems while also giving them the same level of anatomic detail that cadavers typically provide. Unfortunately, as it stands, there is a distinct lack of formal training in radiographic imaging analysis during medical school. A study was done at the University of Kansas School of Medicine, where third-year students were asked to identify CT images of different life-threatening scenarios at the beginning of their third year and then again at the end of their third year. While authors noted a significant increase in correct answers at the end of the third year, the students were only able to identify less than 50% of the trauma CT accurately. This shows us that there is still a learning gap in the current curriculum when it comes to formal training in imaging analysis. We propose that this gap can be solved by using the radiation oncology contouring software, since it provides students with an innovative way to interact with 3D imaging to learn anatomy. Thus, the objective of our study was to assess the utility of contouring software in teaching 3D anatomy to medical students. The design of our study was overall fairly simple. At the University of Oklahoma, we offer a multidisciplinary oncology elective that allows third-year students to rotate through the different subspecialties within oncology. Sorry. I think somehow it exited out. Thank you. Within the different specialties of oncology, these students were asked if they would like to participate in our study, and the participation was completely voluntary. Students were given a pre-intervention survey, which asked them to identify approximately 15 different anatomical structures on CT imaging. Following which, they were guided through a contouring session where they were asked to contour various normal anatomical structures in the body. Finally, they were given an identical post-intervention survey to assess their level of retention. In addition to identifying those structures, students were also asked to rate their confidence for each question on a 5-point Likert scale, ranging from not confident at all to completely confident. We had a total of 23 students who participated in the study with a response rate of 100%. Our data showed a 25% increase in correct answers after the contouring session. So students went from approximately 53% on the pre-intervention survey to 78% on the post-intervention survey. Additionally, this value was statistically significant. When it came to assessing the students' level of confidence, we noticed that across the board, students were more confident in their answers after going through the contouring session. They went from an average of being somewhat confident to fairly confident in their ability to identify structures on CT imaging. To conclude, it is apparent that students in medical colleges are currently not receiving enough imaging analysis training in a world where imaging is being utilized more and more in clinical practice. Our study does have some weakness. Limitations include small sample size, lack of long-term retention data, and resource limitations affecting the widespread implementation of this method. I think regardless of these limitations, our study does demonstrate that we can bridge this learning gap in the current curriculum with the use of existing contouring software or a similar concept. And this will just better prepare medical students for clinical practice. Here are my references, and then just a couple people I wanted to thank. One is Dr. Christina Henson, who was our program director and my mentor, Carrie Postlewaite, my program coordinator, who alerted medical students of this project and streamlined the survey process. And then finally, Paul Pitts, a third-year medical student at our institution, who helped with the data analysis and also with the abstract writing. And thank you for your time, and I can take any questions that you might have.